Okay, so let's finish up 5.2. And then we'll summarize all of our probabilities then. I left off on the top of page 63, I lied, 63. And I had created an extra problem that we barely had time to do as we ran out of time at the end of class. And I can't remember how I worded it. Did I say no more than 3? What did I say for that extra problem? 3 or less? Underneath where it says, for example, 1 above, we did that problem already. I added another one, so way up there near the top, the probability of 3 or less tails. This is not on your notes, we added it up here near the top underneath the top example. It's still referring to the previous one on the previous page where you were flipping a coin 10 times. Jog that memory, remember that? And we had started to talk about, just back up a minute. We were talking about a binomial distribution. Binomial distribution, let's jog our memories a little bit. What's a binomial distribution?
2 variables?
Not 2 variables, but you're close, 2 somethings.
2 nomials.
2 nomials. What? 2 problems? When I flip a coin, 2 outcomes. There's 2 possible outcomes. It's either heads or tails. So you have heads or tails in that case. If someone's having a baby, it's a boy or it's a girl. If I ask if you like ice cream, it's a yes or a no. Anytime where there's 2 outcomes, that's binomial, and then all the outcomes have to be equally likely. And then we had a little bit of notation. We had N, P, Q, X. Let's jog our memory on what those represented. What was N? Number of trials, or the sample size, you can think of it that way. So if I flipped my coin 10 times, I would try it 10 times, so the N would be 10, and I'd have a sample of 10 flips, right? That was N. What was P? Probability of a success, so the probability of a yes to whatever the question might be. If it was the probability of flipping a tails, what would that have been? Probability of tails? I heard somebody, I couldn't hear what it was. 50% or 0.5 or 1/2, however you want to write it. What's Q in words?
Probability of failure.
Probability of a failure. How are P and Q related? They're complements of each other, right? So if P is 0.1, then Q would have to be 0.9, right? They're complements. And then X is what? A specific value from the question. Specific value from the question. So we had already done the problem at the very top where we had said the probability that X equals exactly 5. The one at the very top, the one that was printed on your page, we'd already done that one. We wanted 5 tails, and we used N was 10, P was 1/2, and X was 5. That's what they were asking for. And we used binomial PDF. How did we get there? Distributions. It looks like dister, it's above the bars button, off to the right near the top. Distributions. And then you go all the way down until you found binomial PDF. Let's just jog our memories. Wednesday was a long time ago. Everyone see the distributions button? Distributions, and you have to go all the way down. I think it's the 0. I don't remember how far down it is. A or 0, depending on which calculator you have.
Thank you.
Let me make sure everybody's finding this. Binomial PDF. No, you hit distributions first. Don't hit the stats. Distributions is over there on the right underneath the arrow buttons. You see it? It's kind of up above. By the way, these calculator questions, like, Jill, how the heck do I find binomial PDF? You can always ask me calculator questions on an exam. I won't tell you how to use it, but I'll tell you how to find it. So if you know you want to find binomial PDF and you can't find it in your calculator, I'll tell you where it is. Everyone finding it? And then you either type in your NPX all on one line if you have the older calculators, or you put the N, the P, and X on 3 separate lines. N was the number of trials, P was 1/2 for this case. So in this problem, it was 10, 1/2, and 5. That's the problem we already did. I'm just reminding us because it's been a long time. The weekend made everything fall out of our brains. Or at least shoved them way to the back. Questions?
0.246.
Yeah, it was around 25%. I remember the exact answer. 0.246, you said? If you did not get 0.246 on your calculator right now, please ask me or your neighbor how to get there, because you will not be able to do binomial problems without your calculator.
What does that mean?
Yeah, we're going to talk about what it means in a minute. I want to make sure we have it first, and then we'll talk about what it means. I'm glad you want to know what it means. Anyone still having trouble getting there? So what does it mean? That's the really important question. What does it mean? What was the question?
Probability of exactly 5
The
tails.
probability of exactly 5 tails. So if I flip a coin 10 times, how likely am I to get exactly 5 tails? We think we'll get 5, right? We think we're going to get 5 tails and 5 heads, right? We think we're going to get 5 of each. But how likely is that to happen? How often would that happen?
About 25%.
About 25% of the time. If we change to a percent, it's about 25%. A little bit less than 25%. A lot of people go, Jill, that makes no sense. It's supposed to be 50-50. I'm supposed to get half tails and half heads. But if I flipped a coin 10 times and I got 6 tails, would you be surprised? 6 tails out of 10?
Sure.
Sure you'd be surprised?
In a row?
Not in a row, just out of the 10.
Oh, no.
Yeah.
No.
I think 6 in a row would be interesting. I'd be surprised too. But if out of 10, I said, okay, what if I gave you all a penny right now? I said, flip your coin 10 times. Somebody says, hey, I got 5. And somebody else says, I got 6. The person got 6, would you be going, wow, really? You got 6? Would you be surprised? Some people are saying no. Why not?
It's pretty close to 50%.
It's pretty close to half. We expect to get 5, but one more, by chance that could have happened. Some people might get only 4 tails, and that wouldn't be real surprising. Now, if one of us said, hey, I got all tails, we'd all be going, really? They all were tails? Because that's so far away from the 50% we were expecting. So the reason this is 25% is most of the time, if I gave you all a penny right now and said start flipping your penny, you probably get 4 or 5 or 6 tails. We expect 5, but you might get a little less, a little bit more, and that wouldn't be real surprising. But to get exactly half and half, only 25% of the time. So a quarter of you would get exactly 5 tails. Some would get a little bit more, some would get a little less. Does that answer your question about what that means? So that was the review question. Comments, questions about that one? So now my other question here was, this is the one I added on there. What about getting 3 or less tails? So I hand you all a coin, I say flip it 10 times, and then I say raise your hand if you got 3 or less tails. Do you think a lot of people will get 3 or less if you flip it 10 times? Imagine if you flip it 10 times. How many tails do you think you're going to get? You think you're going to get 5. 4 is pretty close to that. Maybe you could get 3. 2 would be pretty surprising, right? I mean, eventually you're far enough away from that half, you start going, wait a minute. But we don't know how likely it is to happen. So we want to find out how likely it is to get 3 or less. The 3 or less is tricky because what is the specific x value I'm asking about in this problem? 3 or 2 or 1 or 0. Maybe you get 3 tails, maybe you get 2 tails, maybe you get 1, or maybe you get 0. So this is really the probability that x equals 3, or x equals 2, or x equals 1, or x equals 0. Did I write these in reverse order last time? From 0 up to 3? Did I?
No.
I went that way? Okay, I just wanna make sure, I was trying to remember what I did, because we left in the middle of that problem. Okay, that's what it means to get 3 or less? And then we talked about, we know what to do when we see ors. It means we're adding probabilities. So we can do the probability that x equals 3, plus the probability that x equals 2, plus the probability that x equals 1. We can do all those. What would I have to do for each one of these? Like just this one. Binomial PDF, but change the x to a 3 instead of the 5 that we used earlier. So it'd be binomial PDF, it'd look a lot like this one, except it would be 10, 1/2, and 3. And then we would have to do binomial PDF again with 10, 1/2, and 2. You guys following what I'm saying here? 4 different binomial PDF problems. I think we did them real quick at the end of class, did we?
Yeah.
When somebody was giving me the answers. Did everyone see how the x value is changing? The good news is we don't have to do it this way after that. 10, 1/2, and 2. I can barely squeeze it in here. So I'm gonna let you guys start typing these into your calculator. 10, 1/2, and 1. And binomial PDF 10, 1/2, and 0. Oops. 4 different binomial PDF problems, and then we're going to add all those probabilities up. Take a minute or two to see if you can calculate those 4 numbers for me. I think we did them at the end of class last time. I just want to make sure, because we were going quick, we were out of time, we were tired. We were still punching buttons, some of you already have it, I'm gonna start writing them up here and we can check them as we go. What was the first one here?
.1172.
1172, let's just round them 3 decimal places, okay? 117, 044, Everybody get the next one? 0.01. 0.01? 010? If I go 3 decimal places?
0, 1. Because it's 0.0098.
Okay, so it would be 010, right? Mm-hmm. Rounding it. And the last one?
0.001.
0.001. Okay, before we talk about what to do next, I want to know if anybody's having trouble getting those numbers. You need to know how to get them. Copy them off the board's easy. Getting them on your calculator and knowing what they mean is something else. Nobody has a question. Makes me nervous when you guys don't have questions. I'm sure somebody does. So what am I going to do now? Add those all up. And what do we get? Trust you guys to add.
1.1712.
1 point something?
1.7712.
It can't be 1 point anything because
It
that's
must be
higher
under
than 1.
1.1 something.
Oh, 0.1, sorry. I heard the 1 before the point. 0.1, 7, 2. Is that what you said? I heard 1.7. I'm like, wait a minute. What is that? The probability of getting 3 or less tails when you flip a coin 10 times. There's around a 17% chance that could happen. So So if someone says, hey, I got 3, and someone says, I got 2, well, around 17% of the time, someone's gonna get 3 or less. Is that unlikely? Is that unlikely? That word unlikely is crucial in statistics. Who remembers the definition of unlikely?
Less than 0%.
Has something to do with a 0.05? What about the 0.05? If your probability is lower than 0.05, then your event is rare or unlikely.
So it's not.
This is not less than 0.05. So it's not unlikely. Not unlikely. Which means that 3 is not a significantly low number of tails. It seems kind of low, but it's not significantly low. It's not so low that we're like a little confused and worried about it. Okay, so there's a new button on your calculator that's not listed in your notes. We're going to add right here for problems exactly like this. Instead of binomial PDF, it's binomial CDF. The C versus the P. The P is for 1 point exactly. Like you're going to point right at the 5, right at the 3, right at the 1, only one particular X value. The CDF, the C stands for cumulative. And it says, it finds exactly this probability that we just did. It finds the probability of everything from 0 up to your value. So this would find the probability that X is less than or equal to some number. Look at the subtle difference. When we wanted it to be exactly 3, we did binomial PDF. This is the probability that exactly 3 tails. But if we want 3 or less, we're really saying in this particular problem, the same problem we just did, do you agree this is the problem we were just looking at? 3 or less? So then we could have used, now that I'm teaching, you're going to say, why do we do it the long way? I just want to make sure you know what it's giving you. We could use binomial CDF. And binomial CDF does exactly what we just did. It takes the 3 and everything below it all the way down to 0. So let's try binomial CDF with the same information here, right? The N was 10, the P was 1/2, and the X was 3. Put that into your calculator and see what you get. She's over here going, uh-huh. And I think that means she must have gotten 0.172. So it's doing all of this for you. Did we get 0.172? Yeah, that's much nicer, much more convenient. And the reason I just don't tell you how to do CDF versus PDF, I need you to understand what CDF is doing. You need to know when to choose PDF and when to choose CDF. Yes?
So PDF is for exactly and CDF is for less than or
Or equal. Like, so if I say probability of no more than 7 tails, that's 7 or less. So I would do CDF. But if I say the probability of exactly 6 tails, then I would do a PDF.
Is there ever a situation where 5 or more?
Yes, I'll tell you how to do that here in a second.
That was my question.
That was your question too? Yeah. And we're going to think complements to answer those. So we're going to do that here in a minute on my next example.
Oh, there's like, is this the less than, minus, like 1 minus like that?
We are, man.
What'd you say?
Oh, no.
Oh, never mind. You're sitting back there talking about how much fun you're having? Is that what it was?
Just thanking God for the CDF.
Oh, thanking God for the binomial CDF. I'm not so sure it was God, but maybe it was.
Somebody.
Somebody had some direction. Yeah, so I'm very rarely going to expect you to do these all one at a time. But I like to do at least one so you understand what the CDF is doing. Okay, so let's look at example 2. Example 2, we now have a student randomly guessing on an exam with multiple choice. Not recommended, by the way. But now another person is randomly guessing on an exam with 7 multiple choice questions, each with 5 choices for the correct answer. Find the probability that the student guesses correctly on no more than 2 questions. First off, how do I know it's binomial?
It's yes or no, right or wrong.
It's either right or wrong, right?
Two.
And every time you guess, you have the same chances of getting it right. Because you're guessing out of 5 bubbles every time. We see that? That's what makes it binomial. So let's just talk about this. In this case, what is n?
Number of answers, so 5.
The 5 has to do with each individual question, but how many total questions does he have?
Seven.
That's your n. So he's going to guess 7 times, so that's like your number of trials.
Okay.
Where does that 5 come in though?
The probability,
It comes in with the probability. The probability of guessing correctly
1
is 1 out of those 5 bubbles, right? There's A through E, and only 1 out of those 5 is correct, so that's where the 5 comes in. The 7 has to do with he or she, we don't know if it's a he or she, is guessing 7 different times. And the P, the probability of guessing correctly on any one time, is 1 out of 5 bubbles is right. We don't need Q right now, but we will in a few minutes, so tell me how to get Q.
4 or 5?
4 out of 5, why?
The complement of P.
It's the complement. If there's one way to get the problem right, there are 4 ways to get it wrong. Or you could subtract that from 1, and you'd get 4 out of 5. We don't need Q at the moment, but we will in a few minutes. And what is this question asking us to find?
Probability that the student guesses correctly on 2 or more.
Does it say 2 or more? Careful.
No more.
No more than 2. No more than 2, correct. What does that mean? No more than 2.
I think the most I can get is 2.
The most you can get is 2,
You can get 1 and you can get 0.
or you get 1 or 0, so we're really saying 2 or less. Another way of saying that, right? 2 or less, correct?
Yeah.
Sometimes you have to reword it in your own words. And then if we write it as symbols, do we agree that it's less than or equal to 2? So what am I going to do to answer that question?
C.
Binomial CDF, because I need everything from 2 down. Now what goes into my CDF? The 7, because that's my N. The 1/5, because that's my P.
And then 2.
And then the
1,
2.
0.
I'm sorry, say that again.
Oh, do you just do
I don't have to do the 2, the 1, and the 0, because remember, our options are to do the PDF a bunch of times,
for the CD?
or just do the CDF, and the CDF automatically does 2 and 1 and 0. It does everything from that number down to 0. What are we getting?
.85.
0.85, 1?
No, 0.852.
852? Yeah? So there's about an 85% chance that the student's going to get 2 or less of them correct. A pretty high probability of an F. We recommend not guessing on exam. It's not the most efficient method. We all right there? I'm going to add another question on there. Something not working on yours, Kevin?
It comes up quick when it.
Make sure you have the commas.
Yeah.
What's the error say after it says quit? Before it says quit, it should say something.
When I erased it.
Very good. I'll wait for him to get that, and then I'm gonna add another question on here, which is the same question that both of you just asked a minute ago. So add this question on there. The
I
probability
went the wrong one.
of 5 or more correct. Sorry, what'd you say, Kevin?
I went to the wrong one.
Add this question on there now. The probability of 5 or more correct. Same 7 questions. What's the probability that the student will guess correctly on 5 or more? What does that mean, 5 or more? 5, 6, or 7? How would that look like in terms of notation? X is
Equal to
equal to
Greater.
or greater than 5, right? Greater than or equal to 5? This is kind of the question that the two of you were just asking me a minute ago. What if it's a more than? Because what does CDF always give you? Less than. It gives you that number or less. CDF always gives you some number or less. So this requires a little bit of thinking. Just a little bit. We can't do any greater than, we don't have a calculator button for that. But what's the complement of getting 5, 6, or 7 right? Not getting 5, 6, or 7, which would be which numbers?
less than 5.
Less than 5, but specifically which numbers would those be?
4, 1.
0, 1, 2, 3, or 4? 4 would be the highest? So the complement of this, 1 minus, how would I write the complement? Just said it.
Zero.
Go ahead, Evan, what are you going to say? Less than or equal to 4. Why did I do 1 minus? Because I want the complement. The complement's always the 1 minus because they have to add up to 1. I can't do binomial CDF here because I don't have a less than sign. I suppose I could have done PDF 3 times like here and added them all up. I could have done that. The 5, the 6, and the 7 with PDFs and added all 3 of those up. Or I could have said, well, let's think about it. If it's not 5, 6, or 7, the complement would be 4 or less. And now that this is a less than sign, I can do that one on my calculator with the CDF. Look, you guys are really quiet today. It's making me uncomfortable. I don't know if it's you're so lost you don't know what to say, or you're so, you got this, you're getting bored. Or somewhere in between. That's what my guess is.
I think that's the correct guess.
Somewhere in between is correct. Someone want to ask me why I'm doing the complement?
So binomials are always less than
Binomial CDF
C.
is always that number or less, always. And so the calculator does not have something for that number or more, it just doesn't. But we know how to do complements, so we can just find the less ones and then take the opposite and find the higher ones. So I would do 1 minus and I would do binomial CDF here. 7 questions? 7, 1/5, and 4. Everyone okay with what I'm writing and why? Copying it down will get you ready for an exam. Ask me a question. The why is the important part.
So if I did the binomial CDF with the 7 1/5 and the 4 without the negative 1 minus, can I do that second? Can I like do it in reverse order?
If you did the PDF,
No,
is that what you said?
The CDF. Oh, PDF, yeah, PDF.
So if you did the PDF with the 4,
Yeah,
and then and then what?
and then subtract the 1.
Yeah, you'd have to do the CDF because we want 4 or less.
Okay, got it,
See the subtle difference there?
yeah.
Are we looking for the
I wanna know what the answer is to this part. This binomial CDF with 7, 1/5, and 4.
0.29.
729?
029.
What came after the point?
0.029.
Oh, thank you. 029. I can't hear, obviously. 029? That doesn't seem right.
I know.
I think that might be your final answer.
It's 0.995.
Oh, something went wrong. Make sure we're doing CDF. That seems really low.
0.995.
0.995.
The 995s are drowning you out over there, Ariana. Try again. See if you agree with them.
Yeah.
No, yeah, I did the PDF accidentally.
Oh, so it matters, the CDF versus the PDF. What is that 995, the .995, what does that represent? The probability of getting 4 or less of them right. Almost guaranteed that you're getting 4 or less of them right. Right? Almost 100%, almost 1. And if we subtract that, it's 0.005. What is this?
That's the probability.
That's significant, yes.
Of getting 5 or more correct.
This is the probability of getting 5 or more correct if you're guessing. Is this likely to happen?
Negative.
Negative, she says. This is unlikely. Why is it unlikely?
Less than 5%.
It's less than 5%, less than 0.05. This is unlikely to happen, which means 5 is a significantly high number of yeses to get on this exam. 5 is significantly high. Anything that's unlikely is either significantly high or significantly low based on what the question might be. In this case, 5 is on the high end. That's a high number of, I mean, can you imagine if you guessed on 7 questions and you got 5 of them right? That's hard to do.
Buy a lot of tickets,
What'd you say?
and buy a lot of.
Go out and buy a lot of tickets, because you know it's only 5 out of every 1,000 people might do that. So it's so unlikely to happen that he wants to go out and buy a lot of tickets thinking it's his lucky day. Questions? Good news, we're gonna practice more. Good? Maybe? Okay, let's look at that last one on the bottom of page 63. Example 3, we now have that 45% of all blood donors have type O blood. And we're selecting 5 donors randomly. And the first part says create a table to illustrate this probability distribution. We'll talk about that in a minute. The next part says find the probability that at least one donor is type O. I think we can maybe answer that last question before we even know what I'm talking about with that table. What does that problem make you think of when you read the question at the very bottom?
The complement of none.
Aha! She says it's at least 1, which makes her think about the complement of at least 1, which is always none. How many times have we talked about that one already, right? So I'm doing the problem at the very bottom first. At least 1 type O. We agree with Evelyn that the complement is that none are type O? And so every time we see an at least 1 problem, what do we do? What do we do with that complement though? 1 minus, yeah? 1 minus the probability that none are type O? Every time we see an at least 1 question, that's what we've been doing? Even before we learned binomial? So we didn't have to know binomial to do this problem. We could have. I'll show you there in a second how we did it. So if I have 5 people and none of them are type O, what am I going to do? I'm going to find the probability that none of them are type O. I have 5 people. My hint for groups of people or things. Look at them. So review question. It goes all the way back to 4.2 or 3. It's a ways back. So you're flipping through your notes. So my hint is, whenever you have groups of people or things, look at them one at a time. If I have 5 people and none of them are type O, tell me about the first person. They're not type O. And, ooh, did you hear that? And tell me about the second person.
They're not type O.
Not type O. And, what'd you say? And then I end up multiplying each of those individual probabilities. So my hint back in chapter 4 was anytime you have a group of people or things, look at them one at a time and you can multiply those probabilities. I can't remember if it was 4.2 or 4.3. I think it was 4.3.
4-3, is that
4-3?
multiplication?
Yeah, the multiplication and the complements together.
Yeah.
So not type O and not type O and so forth. All 5 of them are not type O. Remember that now? Okay, and when it's an and, we do what? Multiply the probabilities. Well, what is the probability that one person is not type O?
55%?
55%, he says. Where do you get that?
So,
Because 45% is the probability that you are type O, right? If 45% are type O, that's a probability equal to 0.45, right? We're talking about not type O, so what do we do? How do we get the 0.55? Subtract it from 1. If you think about percents, you would have come up with the 55%. So if there's a 0.45 probability that you are type O, there's a 0.55 that you're not type O. So what's the probability the first person is not type O?
0.55.
0.55. And the probability the next person's not type O? 0.55. And the next one? 0.55. And the fourth one,
0.54.
and, I heard that. And the fifth one, try to change the numbers on me. Well, review question. There are problems on the exam very similar to this where you could use a binomial to answer it, or you could use the old rules about at least one and the multiplication rule to answer it. I'm doing the old ones to jog our memories. A shorthand way to write this is 0.55 to the fifth. .95? What comes after the 5?
Like a 9 and then 6.
9596?
No, I
Oh, I
rounded.
got it.
It was like 9.
Oh, does it go to 950 then?
No.
I just want to know what the third digit is if I round.
That's after you subtract.
Right, after we subtract,
Yeah,
what's the answer to 3 decimal places? That's my question.
yeah, it'd be
Or maybe
0.950 if you're.
It is a 0, it's one. We rounded to 0, let's
Yeah.
make sure. I didn't know if we were leaving it off or rounding. You okay with that? So, what did we just find right here? That none are type O? None are type O, this part right here. That's what this part is, right? Nobody's type O. How many people is that? That are type O if it's none? Trick question. None means how many are type O? 0. We're really talking about none are type O. Is the same as saying 0 are type O. Excuse me. 0, they're giving me an X. Aren't they giving me an X if they're saying 0 or type O? So what's another way to find this using binomial? If I want the probability that 0 of them are type O,
Could you use,
PDF.
I'd use PDF, because I'm talking about a specific point. Binomial PDF. And what would I put in there? And n comes first, so what's n in this case?
5.
5. What's the p? Is it 5, or 4, 5? It's the 4, 5, because we're talking about type O, being how many of them are being type O? 0.45? Oops, lost my point there. So this is how many people, this is the event we're looking for, type O. And how many do we want? 0. Type this into your calculator. I'm squeezing this corner here, sorry. It should be the same as what I have in my red box down here, which I haven't simplified. We should probably write that out. Should be like 0, 5, 0, something like that. What's 0.55 to the 5th? Same thing. So this is using the multiplication rule. That's recognizing it was binomial. Either way, we have to take 1 minus that, and we're going to get the same answer either way for this problem. I can't stress that enough, is that our binomial is just a special case of the multiplication rule. So there's times on the test where you might use binomial, you might use multiplication. I don't care which way you do it, it'll work. Put your hand? Yes.
So how would we think of this problem as being binomial?
So every person is either type O or not. So those are your two options. Are you type O? It's a yes or no question. Right? So if I come up there, are you type O? You're going to say yes or you're going to say no. So those are
So
your...
we wouldn't think of like how there's more types than just O or not?
You could. There's a lot more types than O. But since this question is just asking about the probability of being type O, that makes it a yes or no question. Because all the other ways, all the other types of blood get lumped into that O. There's basically O and not O. It's kind of like if I asked you your favorite flavor of ice cream. And I want to know the probability of some certain number of people saying chocolate. There's a lot of other flavors, but basically it's either chocolate or not chocolate. So that's what makes this one binomial. So you're right, sometimes there's more than 2 outcomes, but the way the question's phrased makes it only 2, makes it a yes or no. Okay, so let's go back to the part where it asked about the table. When it asked about the table, the problem is what there? Do we know n and p? For this problem, example 3, we know n and p, but the table doesn't give us anything about an x at all. Right? Doesn't give us anything about an x. So here's what the table does.
5?
I'm sorry, say that again?
Isn't x 5?
That would be if the question, so his question was, isn't x equal to 5? X would equal 5 if I said, what's the probability that all 5 of them are type O? I'd be giving you a
X
number.
and
Yeah,
zero
n,
and 5
yeah.
again.
N is the 5, but X could be then 0 of them are type O, or 3 of them are type O, but there's no question here, so there is no X. So let's talk about all the possible X's we could have with this problem. So we're creating a table, X and P of X. Out of 5 people, how many of them might be type O? Could be none of them. Ooh, we already found that probability. We just found that, right?
2.9.
It could be one of them is type O. It could be that 2 of them are type O. It could be 3 or 4 or 5. Those are all the possible answers if I had a group of 5 people. Remember making those distributions last week, early on? So we could do binomial PDF all these different times to get these answers. Binomial PDF with x equals 1. Binomial PDF with x equals 2. Binomial PDF with x equals 3 to fill in this table. We agree what I'm talking about there? That's how we get all these. But there's a shortcut. The shortcut is to do binomial PDF, tell it your n, tell it your p, and don't bother telling it an x value. Leave off the x. Leave it blank on your screen if you have the screen that asks for x. Just don't put it in there at all. if you have the older calculator, and you should get a list of numbers that you can scroll across. And this should be the first one. You should get a list of numbers and you can use your arrow button to look at them all. I want to see if we get to that screen first, and then we'll start copying down those numbers.
And then just leave the X value empty.
Leave the X value empty. And you should get a list of numbers, and this should be your first number in your list. If you're not getting that list, I want to look at your calculator, or have your neighbor look at your calculator. Come peek at yours. Excuse me.
What if the list doesn't move?
If you hit enter, it won't move. So do it again, and don't hit enter after the list comes up, then you can move. Yeah, sometimes people can't scroll over, and that's because you accidentally hit enter. You start over. Once it comes up, just immediately hit your right arrow. So now just go to paste. Yeah, hit paste, and and then enter. Now you can go over. Don't go down, you went down.
yeah,
Don't go down, just go over. Once your list comes up on your screen, don't push the down button, just push your right button. Just go to the right, otherwise you can't see them all. He finally figured it out after he did it wrong twice. It's tempting to go down, just push your right arrow button and you'll move over. Can you move over to see them? Yeah, let's just go over. Yeah, so you can keep moving back and forth to see all of them. And what we're gonna do is we're gonna copy them all down here. Anybody else having trouble? Yes. I'll close the parentheses. Hit enter. Oh, go back and see what it was. Oh, it's 0.45. It has to be a probability. That's why I didn't like it. 0.45. Yeah, it's always a probability. Then it'll work. Now you can use your arrow and move over and see them all. Okay, anybody else? So those numbers are all of these probabilities in order. So the very first number has a whole bunch of digits. What's it say? 0.05, what's it?
0.328.
Yeah, it just keeps going and going and going. But we're just going to round it to 3 decimal places. And what's the next one? 0.26?
No, 206.
206, thank you. 0.206. What's the next one?
337.
337. I'm assuming you guys are rounding.
Yeah.
Yes?
Yes.
Next one? 276?
113.
113?
018.
018. So this is like those probability distributions that I gave you in 5.1, where I said, here's the table, what's the probability of exactly 4? If I ask the probability of exactly 4, it'd be 0.113, it's right there in front of you, right? And if I said, what's the probability of exactly 2? You'd say, oh, it's 0.337. So this gives you all the probabilities, so you can just look at them easily and answer any questions. Let's go back and look at this question now. At least one of them is type O. At least one means one or more. At least one is one or more, right? One or more is everybody below this red line. Do we agree that all of these, 1 or 2 or 3, that's at least 1? If it could be 1 or 2 or 3 or 4 or 5, guess what all of these add up to? All of them just in the red box. Take the 0.05 out, he says. They add up to 0.95. That's what we found. If you want to, for fun, add all these up. They should add up to 0.950. They might be off because we rounded, but it should be pretty close. Or, I like the way Kevin looked at it. He goes, why not just take this one off? Just take that one off, right? Take it off from 1, because this is the red box down below is the complement of what's up here. So 1 minus this guy is everything down below. So there's 3 different ways to do this one problem. You could look at it as a multiplication thing. You could make a table and just count the ones you want. You could look at it as binomial and use your binomial PDF or CDF. Questions? Yes.
For the binomial PDF, I see how we got 5.45, but then for the x value where it says 0, I'm a little confused how we got.
Why we did that over here?
Yeah.
Because for this particular one, we were worried about none are typo.
Oh, okay.
And if it's none,
Sure.
that's the same as saying 0.
Got it.
Other questions? Okay, let's take a 10-minute break. We'll come back and we'll do the last little bit of 5.2 and then we'll do some practice. We'll see you in 10 minutes.
I got 0.
Okay, so let's continue on. We got one more page of 5.2 here. And then I'm going to set you loose to try to think for yourself, hopefully. Page 64. Page 64. So the binomial situation comes up so often that we can actually find out information about the whole population, just because similar to how we can get all of the possible outcomes with our calculator all at once. So we could actually find the mean and the standard deviation for this population if we wanted to. Imagine, I think we talked before, if a family has 6 kids, how many girls would you expect them to have if they have 6 kids?
3.
You'd expect them to have 3. It's not guaranteed, but why do we expect 3? Because it's a 50-50 chance. We expect half of them to be girls, so half of 6 is 3. If I flipped a coin 70 times, 70, how many times do you think it would come up tails? 35, she says. She took half of 70. And what we're really doing is we're taking that half of 70, or we're taking half of 6, whatever it might be. We're taking the p, the probability of a yes, and multiplying it by our n. What about the multiple choice questions, like where you have 5 options? You know, the ones we were just guessing on before with the 7 options? If you have 5 options and I answer 5 questions, how many of them do you think I'd get right? 5 multiple choice questions, if I'm guessing, how many do you think I would get right? Probably just 1, right? 1 out of every 5 we expect to be right. So if I asked 5 questions, I'd expect to get 1 right. What if I answered 10 questions? I'd probably get 2 right. With 1 out of every 5, that'd be 2 out of 10. So what we're really doing is we're finding the mean. So on the top of page 64, we can actually find the mean, the standard deviation, and the variance for any binomial distribution. And there's actually these really nice short formulas. The first one for mean, mu, is n times p. However many things or trials you have, things in your sample or number of trials, and p times the probability of a success. Technically, that's what I was just doing. If I guessed on 10 questions, and I had a 1/5 chance of guessing them right, you guys all agreed with me that I'd probably get 2 of them right. That's kind of what we were just doing in our heads. So that's where the n times p comes from. We can also find the variance. The variance, remember the symbol is sigma squared, n times p times q. Remember I said we're going to need q here in a minute? Now q comes up. And then how did we find the standard deviation from the variance? You guys remember from way back when? How are sigma squared and sigma related?
Square root.
That's just the square root of it, which is where that formula is on there for you. N times p times q. All we have to know is N, P, and Q, and we can find, actually N and P, we can find Q, and then we can find the mean, standard deviation, and so forth. So let's look at example 6. Example 6. So now we've got a final exam in sociology. There's 100 multiple choice questions. This time each question only has 4 possible answers. So you don't have like 5 bubbles to choose from, you only have 4, like A through D. A, B, C, or D. Right, 4 possible answers. Only one of them is right. And an unprepared student, of course, makes random guesses on all 100 questions. It just makes a little pretty picture with all of his little bubbles. Okay, so we want to find the mean and the standard deviation for the number of correct answers in this case. First off, what's N? 100, right? He's guessing on 100 questions, that's our N. He's guessing 100 times, 100 trials. P in this case is the probability of guessing correctly.
That one,
On-
10 out of 100?
On each one question. So imagine if it's just
4.
one question, there's 4 bubbles,
Yeah.
and only one of them is right. So what you're saying though, Brian, is really common to try to put it together with this.
Right.
So the P always talks about 1 at a time. Who cares how many times you're doing it? Each time I hand you a question, there's a 1 out of 4 chance of getting it right. Agree with that? So what's the chances of getting it wrong? 3 out of 4, right? Because these are always complements of each other? Good. So the directions say for part A, find the mean and the standard deviation for the number of correct guesses. How am I going to find the mean? N times P. Mu equals N times P, which in this problem is 100 times 1/4,
25.
which is 25. You would expect him to get 25 out of 100 questions right. That's 25%, right? 25% is 1/4. That's 1/4 of them right. Again, guessing not recommended. Now that's a low F, that'd be all bad. So that's the mean. How am I going to get the standard deviation?
Square root, I mean.
I'm going to take the square root of
3/4 is 1/4 of 100.
100 times 1/4 times 3/4. The N times the P times the Q.
12.33?
That's your whole answer? Most people will do the inside first and then do the square root, but if you want to type it in all at once, you can do that as well. Do we agree with Hector's 4.33?
I did the variance first, man.
You found the variance, then took the square root, that's fine. So he says he did this first. N times P times Q, took that answer and then just took the square root of it. What was the answer before you took the square root? Did you write it down?
Yeah, it was 18.75.
So when you multiplied those 3 out, you got 18.75. And then when you took the square root, is where you got 4.33. We're getting those numbers? Okay. Now, before we go on to part B, the book starts talking about the range rule of thumb pretty soon. It throws this at you. It's not written in our notes anywhere. Range rule of thumb. Squeeze that in there somewhere. Remember our original definition? Oh, actually it's up above. I skipped over it. See up there, the 4th line down where it says unusual? We changed that to significantly high or low. Right, every time we saw unusual, we've been rewriting it as significantly high or low. So cross off the word unusual. Change it to significantly high or low. And remember that definition? More than 2 standard deviations away from the mean? That was how far above it or below it you had to be significant? That's the range rule of thumb. So there'll be homework problems that say, use the range rule of thumb to decide what cuts off something that's significantly high or significantly low. They're really talking about the definition of what that means. More than 2 standard deviations away from the mean. Put a little note there next to that line, 4th line, and say range rule of thumb. That's what they're talking about. Now, in our question B, oh, that's the typo I was looking for earlier. It still says unusual. Would it be unusual for a student to randomly guess and get at least 35 questions correctly? Really, they're asking, is 35 significantly high? So question B could be reworded as saying, is 35 significantly high? Because remember, the mean is the expected value. We expect if somebody guesses that they're going to get 25 right. If somebody just guesses on 100 questions, we expect they're going to get 25 correct. And question B wants to know, well, if they got 35 right, is that really significant, or could that have just happened by chance? Everyone okay with the question? There are 2 ways to answer it. One's with probabilities. The other one is by using the range rule of thumb. Remember our picture. The mean goes in the middle. The mean was 25. And then we added 2 standard deviations and we subtracted 2 standard deviations.
Are the standard deviations going to be the 4.33?
Yes, standard deviations of 4.33. So if we add 4.33, this one would be 29.33. By adding 4.33, can you close the door, please, Wanda? Thank you. And then I'm going to add 4.33 again. 33.66. So anything past here, anything that way on my number line would be significantly high. That would be a really high number of questions to get correct on this test. And if we go the other way, subtracting 4.33, this will be 20.67. I'm subtracting in my head. Somebody help me out here. Yeah? Thank you. And 16.34. Don't trust me to subtract in my head.
Yeah.
Yeah? Where am I getting those numbers?
Subtracting and adding 4.33.
Adding and subtracting 4.33. Remember, sigma was 4.33. So we add, we subtract. Anything down this way is significantly low. So I like to think of those as surprising. It would be surprising if somebody guessed and got more than 33.66 questions right. It would also be surprising if you got less than 16 of them right. I mean, it's hard to get that many wrong, even if you're guessing. Sometimes you guess right. So the question for part B that actually says here, would it be unusual? It's the same thing as saying, is 35 significantly high? And the answer is? Yes, because it's past that cutoff. This is the cutoff for what makes something significantly high. So since 35 is past that 33.66, 35 is over here somewhere. That's past that cutoff, that is significantly high. Yes?
So what can we say for because?
Okay, good question. Did you hear what she said? She says, because, what should we say?
It's more than 2 standard deviations away.
Beautiful. It is more than 2 standard deviations away from the mean. This is the same thing we were doing back in chapter 3. It's going to keep coming up all semester long. Yes?
I was looking at C,
Mm-hmm.
and I'm not sure how to answer because it's 20 or less.
Mm-hmm.
So 20 is only 1 standard deviation away, but anything under that
Under
would be.
16 is.
Okay, so 20 or less means everything from 20 and below.
So it'd still be no then?
So it would be a no, so let's talk about that. Is everyone okay with part B then, where we were done with that? So the 20 or less, Kirsty goes, wait a minute, some of those are unusual, but you always take that highest one and decide where is that highest one, and the highest one, the 20, is roughly right here.
So,
That's not more than 2 standard deviations away. So imagine if I started there and continued off going to the left, they wouldn't all be 2 standard deviations away. So as soon as they're not all out there, because 35 or more is 35 and everything keeps going out that way, so they're all of them are more than 2 away. But 20 or less, some of them are, some of them aren't, so the answer is no. It's a subtle distinction there. So for part C, the answer is no, because,
It doesn't ask for why.
but I still want to put the why so we know why the answer is no. Because when you're looking at your notes later, you're going to know why is the answer no. And on an exam, I always ask for why to make sure I know what you're looking at. No, because
It's only one standard deviation.
away.
20 is not 2 standard deviations away. Neither is 19, neither is 18, neither is 17. There's a lot of them that aren't more than 2. So we wouldn't say 20 or less because all of them aren't 2 standard deviations.
Did you answer a no because it's only one standard deviation away?
That's fine too. It's telling me that you know it has to be at least 2 to be unusual or significantly low or high. We all right with that? Let's try the next one. Now we're going to Denmark and we're worried about cell phone users. Example 7. We have just over 420,000 cell phone users in Denmark, and 135 of them developed cancer of the brain or nervous system. So someone's worried that maybe it's because of the cell phones. If we assume that cell phones don't have any effect on that kind of cancer, then we have this probability of just getting that cancer, whether or not you have a cell phone doesn't matter. So we have this probability there. And then it says for part A, assuming that cell phones have no effect on developing this cancer, find the mean and standard deviation for the numbers of people in groups of 420,095 that can be expected to have cancer of the brain or nervous system. What the heck do they want me to do? Multiply n and p, she says. It says find the mean. Find the mean, right? This is the mean. This is the standard deviation. This is the variance. Let's make sure we know what everything is. What's n in this case? That's 420,095. That's our n. What's our p?
0.00340.
0.0000340. It's a very tiny probability. Really unlikely that any one person will get this kind of cancer. That's good to know. What's Q?
Would it be the 135?
Did you subtract that from 1 to get it?
We would subtract it from 1 because it's always a complement. Is that what you were saying too, Karen? Because it's a complement, we have to figure out what that is. 1 minus 0.000340
99966.
is 99966. That's the probability that somebody won't get that kind of cancer. I like to write my N, my P, and my Q before I get started so I don't have to go find them in the middle of the problem. So part A says find the mean.
It's just N and P, right?
It's just N times P.
I got 142.8323.
Tell me again.
I got 142.8323.
833?
8323.
Do we agree with her? Yeah? Get some nods? So we would expect that out of 420,000 people, about 143 of them might end up with this kind of cancer. It's the average. The mean is another name for the average. An average, the expected value, so we would expect that many to have it. Kind of like we would expect half the coins to be tails, so we would expect in this case. That's the mean. And it also wants standard deviation. So what am I gonna do there?
You're gonna square root NPQ.
Square root of n times p times q.
Like 11.95.
Write this all in here and I'll copy down what you just said, Jenna, hang on. 11 point what?
9.5 if you're rounding.
Okay. Do we agree with it?
Yeah.
Some people are still pushing buttons, I hear them clicking.
So
No
how would you
questions?
say the standard deviation, like, and we can expect from that 142 that there'd be like an 11%
Yeah, it wouldn't,
difference? Like-
yeah, so if someone, let's call it around roughly 12. If we expect around 143 people to have those cancer, that type of cancer, on average, people are 12, there's groups of 420,000 people would be 12 away from that. So if this was, 12 higher or 12 lower is what you would expect. Anything more than that 12 twice, though, would be extremely unusual or significantly high or significantly low. So that's kind of telling you how far away from the middle you could go before it starts to be kind of weird. Like, wait a minute, something's going on here. Just like my coin, I expect it to be, half the time tails, but at some point that's too many tails. And so that tells you what that cutoff's going to be for how many is too many or how few is too few. You okay with that part? That was part A? Part B is asking the same thing that last one just asked. Based on those results, is it unusual to get this 135 that they actually found? And so another way of asking unusual is it significantly high or significantly low? Is 135 significantly high or low? How do I answer that? Some of you are shaking your heads no at me,
Check
but
the standard deviation, it's not a full standard deviation away from the mean.
it's not even a full standard deviation away from the mean. So I'm going to draw the same picture again here. Get rid of my little stars. What am I going to mark on my number line here?
Put the mean.
142.
The mean, I'm just going to round it to 142.8, just so it'll be easier to write them on here. 142.8 is my mean.
And then we add 12 or subtract 12.
Yeah, I can, if I want to round it, I can even round it to 12. If I go to the tens place, that'll just be easier. I'm rounding those. So if I add 12, that will be 154.8. If I add 12 again, that'll be 166.8. And if I subtract 12, I get 130.8. And if I subtract 12 again, 118. I think.
Close enough.
Close enough. So these numbers right here, by the way, these numbers right here are the numbers that are the cutoffs for what makes something significantly high or significantly low. When you read about the range rule of thumb in the homework, it'll say, use the range rule of thumb to find those numbers to separate those that are significantly high or significantly low. Well, this number right here separates the significantly high. This one separates significantly low. So this problem, there were 135 people that had cell phones that got this cancer. Where's 135 in here? It's like in here somewhere, right? 135? Is that significantly high or significantly low? No, it's within that, what I like to call the usual range. Not uncommon to be in that range anyway. It's actually a little bit less than what we expect. We expect it's a little bit, we expect around 143 people. 135 is a little less than we expect. It's not extremely less that we would say that's significantly low. So the question for part B was, is it unusual for a group to have 135 cases? No. It's within 2 standard deviations. And then the big kicker is question C, which is why we do statistics. So someone came along and said, hey, I think people in Denmark are getting more kinds of this cancer because of the cell phones. We need to see if there's maybe an issue here. And we just found that the number that they got was not anything unusual. It could have just happened by chance. So based on these results, what do these suggest about the publicized concerns that cell phones are a health danger because they increase the risk of this cancer?
There's no correlation.
We don't see any relationship, right? We don't see that there's an increased risk. Where would that number have had to be on this number line for there to be an increased risk?
166.8.
Something higher than 166.8. Anything higher than that would have been significantly high and unlikely to happen. Then we would have said, wait, maybe there are some concerns. But because we're within the usual range, there's no concern. Somebody thought there was, but statistically we've just shown that there is no concern. No reason to be concerned. Questions then? Okay, so I'm going to hand you now extra credit quiz number 3, which is asking you these same types of questions as what we just did, in addition to asking you probabilities at the same time. What if I had asked you for the probability of 135 or less in this particular case here? 135 people or less, and I wanted to find the probability of that happening. I would do binomial, and since it's 135 or less, I would use CDF. If I asked for the probability of x less than or equal to 135, we would have used binomial CDF. With what numbers? With what numbers if I was doing binomial CDF? What's my N? 420,000 and some change. What's my P? 0.00340. And what's my X?
0.
What's my X in this case? 135. Based on these results here, do I expect to get an unlikely probability? Someone said no. Who said no? So you, Phoebe, why is it no?
Because it's within 2 standard deviations.
Because it's within 2 standard deviations, it's not far enough away to be unlikely. So this answer right here should be something larger than 0.05 because it should match up with the same decision here. The decision you make with the graph, it should be the same decision you make about the probability. I'm going to